Today we are going to see how to use your Vivado. Right? I have a Vivado 2023 version. So you'll get a screen like this. Already I have opened, so I am getting a screen like this. Once if you are clicking onto the Vivado, you will get a screen like this. Move on to the file, new project. Next, give the name for the project. I'm going to do the full adder. Next, next. If you're going to use the hardware, you can move on to the board. If not, move to the next and finish. Already it was open, so it is asking whether to close the previous project or not. Close the previous project, right? So new project has been created. It was initializing, so we have to wait for some time. Once it has been created, you will get a reward screen, which was seen already. Project has been created, it is updating. Once updation has been completed, we can proceed, right? So once if you got this screen, move on to add source. So this add and create design source, which is used to write the coding, you'll get an edit screen. So for that, create a file to write a code. You can give the same name or else you can give the different name. I'm giving the same name, full add. Click on to the OK and finish. Click OK and yes. It is asking, are you sure you going to give save the same name? So I have given S. It is updating. Once updation has been completed, you'll get a coding name which have been saved under your design source. So updation has been completed. Click on to the design source. So whatever the name you have given for the project that was displayed here, click on to this. You will get a editor screen. So in the screen, you're going to write the program. I'm going to write the program for full adder. A comma, B comma, C comma, sum comma, carry. So once I've completed, write the input A comma, B comma, C, semicolon, enter, output, sum comma, carry, semicolon, enter. I'm going to use a data flow. So whenever you're writing the program under the data flow, you have to use your assign, ASSIGN, assign. I'm going to write the program for sum. Sum equal to A XOR B XOR C semicolon. Next, we are going to write the carry, again assign, carry equal to open bracket A and B close bracket plus open bracket B and C close bracket plus open bracket C and A close bracket semicolon. So we have completed the sum and carry. Once I have completed, save the project, right? Your program is correct. So you got a green symbol here. So if you're getting a green symbol, it shows that we don't have any error in the program. Save it. Next, we are going to write the test bench. Again, just a minute. Yeah, completed. Now add source. Now add and create simulation source. This is for your test bench. Move on to this. Create a file. You can give a different name or the same name with tb full add TB is representing your test bench. Okay, finish. Again, okay, and yes. Now the test bench has been created, which will be there under your simulation source. So test bench has been created. If you see the sim underscore one, your coding is there as well as your test bench is there. Click on to the test bench. You got the test bench. Already I said either you can have the brackets or without this brackets you can have it, right? Both are correct. Enter your input. In the coding, input is represented in the test bench is represented as register a comma b comma c semicolon. Output is represented as wire sum comma carry. Enter. Now you are going to do the instantiation. So to do the instantiation, go to the code, copy this and paste it here, and dut. This is for your instantiation. Whatever input and output is there, a comma b comma c comma sum comma carry. Write everything. Close the bracket. Semicolon. Enter. Next, initial. Always you have to write the initial whenever you are writing the test bench. After your initial, you have to do the begin. Enter. Now you are going to give the value for the inputs. How many inputs you have? A equal to 0 semicolon, B equal to 0 semicolon, C equal to 0 semicolon. Right? So I'm copying this. Initially I've started with 0, right? I'm going to give some time delay. So after 2 seconds, I'm going to get the next value. So what is the next value? Again 001. Next, copy this, change the value, enter, paste the value 010. Next, paste the value 11, and next again paste the value 100. Next, paste the value 101. Paste the value 110. Next, paste the value. Everything should be 1. I've given all the values. I've taken all the options. Now, just see the time delay. If you are representing all the time delays equal mean, that means in the same time delay, you will get an error. That means you will not get the proper answer. So you have to change the time delay. I'm changing 5. Randomly, I'm changing 7, 9, 11, 13, and 15. So I've completed everything. Just check once. Did I do any mistake? Yeah, I did a mistake because I didn't end with your test bench. End. I've completed. Now everything is completed. Right? Just check once. Any other mistake we did. Some carry, instantiation, initial, DUT, A equal to B equal to everything was correct. We have completed. So just you see the screen, you got the green. So there is no error under your test bench, and save it. It was updating. Once it is updated, move on to the run simulation. We have to wait for some more time. Once the updation has been completed, we can simulate your project. It is updating. Yeah, updation has been completed. And still it was updating. You have to wait for a moment. Yeah, it was over. Just wait. It is completed. Now move on to the run simulation, run behavior simulation. Once this is completed, you will get an output for the full adder. So what is the concept of a full adder? If you are adding a plus b plus c, you are going to get the answer by sum and carry. So what is the answer? I think you guys know the truth table for your full adder. Just check with your truth table along with your output what we are going to get now. So if you see the output, you can able to understand how we got the output for your full ladder, right? So you're going to get the output only through your timing diagram. So by checking your timing diagram only along with your truth table, we can see the output. We have to wait. It was running. So once it execution has been completed, you can get the output. So to see the block diagram, you can go with your open block design, or else you can see the open elaborated design. So if you see there, you can see the diagram for your full ladder under your Vivado. Just takes some more time to execute your program. Check the output. If you see this, you can see all the outputs. It was showing your 50 nanosecond. It was 0, right? If everything is 0, your sum is 0 and your carry is 0. Next, we want to check your time delay. Initial is 5. Sorry, initial, the next one is initial is 0, next is 2. Next is in the 2 nanosecond, your carry is 1. That means C is 1. The remaining 2 is your sum is 1. Next is 7. Next is 7 plus 2 is 14. Next is 19. Sorry, 23. And next is 34. So based on this, you are creating the time period, or else we'll check with the 2 nanosecond for all. Let's see what is going to be the answer. 2 nanosecond. It was simulating. Just a minute. Yeah. Now we'll check the output. Go to the run simulation. It shows error actually. Let's see what error is showing. So it is not showing. It's showing an error. So we'll do like this: 2 second, 3 second, 4 second, 5, 6, 6, 7. So keep on. We have increased the time delay. We have to add and we have to check the output. Now we'll move on to the run simulation, run behavioral simulation. We got the output for the full ladder. Just move the screen to check the output. 0, 0. Your summon carries 0. For the 1 nanosecond, C is 1, sum is 1. For 3 nanosecond, again B is 1. So like this, you have to check your output. How you are checking your nanosecond means you go to the test bench. If you see the test bench, for the first nanosecond, your C is equal to 1. That means A plus B plus C is equal to sum is 1, carry is 0. For 1 plus 2, at 3 nanosecond, you have to check the output. Up. Then 3 plus 3 is at the 6th nanosecond, you have to check the fourth output. And 4 means 6 plus 4 is 10 nanosecond. 10 plus 5 is 15 nanosecond. 15 plus 6, 21 nanosecond. 21 plus 7 is 28 nanosecond. So you have to check the output like this based on the timing diagram which we have received from the Vivado. So like this, you have to proceed with your Vivado. Thank you.